the center of mass. Any object has a center of mass. For example, if we take this object, the center of mass of this object will be uh, at the midpoint, at the center, at this point. And if you want to draw the weight, you will get here mg. I give you another example. Let's say we have a road, a homogeneous road, okay? As you see, the center of this mass, it will be at the center here. And if you draw the weight, it will be also at this point, okay? So this point and this point are the center of mass. And here we have center of mass. Now we are talking about a symmetric object, as you see, the sphere and the road. Now let's take, we have a more complicated system. We have this road, for example, okay, like this, and here I need to calculate before we have a small object here of M1. So we have the road and we have M1 here. And let's say we have M2 here. So here we have M1, here we have M2, and we have the road. You know, the center of mass of M1 will be here. So here we have M1G. And the center of mass of M2 will be also at the center of the object. And the center of mass of the road will be here. So here we can write the center of mass of this object. Here we have Cm for this object, and here we have Cm of the road. Okay, if we have this object, the total object, how can we find the center of mass of all this object? Okay, we need to calculate its value exactly the position of this center of mass. So in general, we have to calculate the position of the position of the center of mass. Okay, this system contains of M1, M2, and a road. So we have here M1, we have M2, and we have the road. Okay, in general, to calculate the center of mass, let's say we have x-axis here. Okay, we are working on the x-axis. So we have to find the position of the center of mass on the x-axis. We can say also we have to find x of the center of mass total. Okay, total. In general, equals to summation of m I xi divided by the summation of m I. What I mean by this relation, you can write summation of mi xi, it means we have m1, for example, we have m1 x1 plus we have m2 x2 plus we have m, let's say we have m capital, we can say mr xr, okay, divided by m1 plus m2 plus mr. Okay, let me explain what I mean by x1, x2, and xr. Here, I want to put the x-axis and y-axis. For example, as you like, maybe I put the x-axis here and y-axis at this point. Or we can put x-axis and y-axis at this point, as we like. Okay, let's say, first of all, I put the x and y at this point, at the edge of the road. Okay, and also we have the road of a length L. So the distance from here to here equals to L. So the distance from O to the center of mass of the road equals to L over 2. And the distance between the center of mass of the road and the center of mass of M2 also equals to L over 2. Okay, it's just an example. So I have to find the position of the total center of mass. I don't know till now exactly its position. Okay, let's say with respect O, we have, first of all, x1 is the distance between the center of mass of x1 and O. Okay, so let's write here. X1 is the distance between O and M1. Okay, or we can say better between O and the center of mass of M1. X2 is the distance between O and the center of mass of M2. And XR also is the distance between O and the center of mass of the road. We come here. Here we have O. The center of mass of M1 is here. So the distance between O and M1 equals to O. So here equals to O. 0. Second, M2 times X2. X2 is the distance between O and the center of mass of M2. Here it's equal to L. So we get here M2 times L. Okay, plus M of the road times XR. XR is between O and the center of mass of the road equals to L over 2. So we have L over 2 divided by the mass of the total system. It's equal to M1 plus M2 plus MR. Let's say here as a given, we have M1 equals to 1 kilo, M2 equals to 2 kilogram, and the road has a mass of let's say 1 kilogram. So finally we get M2 equals to 2 times, and let's say also we have the length of the road L equals to 1 meter. So we have 2 times 1 plus, let's say we have to simplify, just to simplify the calculation, L equals to 2 meter. So we have M2 times 2 plus MR equals to 1 times L over 2 equals to 2 over 2 divided by the summation of the mass. Here we have 1 plus 2, 3 plus 1, 4. We get here 4 plus 1, 5 over 4 meter. Okay, I think it's about 1.25. Okay, here we have 1.25 m. We come here we have O, the distance between this point and this point equals to L over 2 equals to 1. So 1.25, I think it's here. This is the position of the total mass of the system. Okay, here we can say the weight of the system will be mg, m equals to m1 plus m2 plus mr times g. Okay, this is if I take the x-axis at the point at m1, you will get the same result if you put this axis any other point, at any other point. Let's say, for example, if I put the x-axis at this point, okay, at this point, this is the point O. Okay, I put this axis at the position of the center of mass of the road. In this case, we have to see x1. X1 is a position between, here we don't have O, is a position between O and the mass m1 equals to minus L over 2. So here we can write m1 equals to 1 times x1 equals to minus L over 2 equals to 1 equals to 2 over 2 equals to 1. So minus 1 plus m2 is here. So m2 equals to 2 times the position x2 from O to this point equals to L over 2 equals to 1 plus mr equals to, this is mr equals to 1 times the position between the center of mass of the road and O equals to O. So equals to O divided by the summation of m1, m2, and we get 4. The answer will be minus 1 plus 2 plus 2 divided by 4. We get 1 divided by 4. It will be 0.2. 0.25 meter. As you see here we have the center, and the position here will be at 0.25 meter. We get the same result as the total center of mass. Okay, also you can try if you put the x at this point. At this point, we have x1 equals to minus L, x2 equals to O, and xr equals to minus L over 2. And also you can try, you will get the same result. Thank you.